So what we do is, this is a very simple graphical construction, right? This is something that you, in the beginning, maybe you'll draw on a piece of paper just to figure out the directions, but pretty soon you will see that you won't have to do it. You'll draw these circles in your head, and you'll be able to see it. Okay, so coming back to the same wrench and nut problem. So let's say we have this force F1 acting this way, okay? And this is not necessarily, perpendicular to this line, right? We have this force F1, and we are trying to compute the moment of this force. Right? Moment is a vector quantity. It has direction, it has magnitude. Magnitude part we just saw. So we know the magnitude of the force, we multiply that with the perpendicular distance from the point of action. So we're not talking about that over here. This would be the perpendicular distance, and the moment would be F1 times that distance, whatever that may be. So the question is, what is the sign, what is the direction of this moment? So what you do is, choosing the point of pivot or the point of interest as the center point, draw a circle of the radius equal to the perpendicular distance. So when you do that, essentially you will have a circle that will be tangent to this line of action. Right? Or what you can do is, you can say, hey, I believe in geometric construction, I will choose this as my center point, and I will draw a circle that will be tangent to the line of action. So if you do that, the radius of that circle would be nothing but the perpendicular distance. Right? Now imagine that radius is actually a wheel, okay? And if that's a wheel which is constrained to rotate about the point of interest or the pivot point, and if you push this wheel in this direction, which way would the wheel rotate?
Clockwise.
Clockwise, right? It's going to rotate clockwise. Now clockwise direction for the moment is considered to be a negative direction. So that quantity is going to be negative. So we may write that this is a clockwise, moment is a clockwise, but to do the algebra, you will put a minus sign in front of the magnitude cone. Okay, so clockwise is negative. Now, of course, moment is really not in this plane. Remember that. The moment is not in the plane. Moment is actually in direction perpendicular to the plane of the line of action and these distances. Okay, remember, all the distances, all the forces are in one plane. The moments always act perpendicular to them because of the cross product rule. Okay, so because of the cross product rule, the moments are always perpendicular to that plane. Either they are above the plane or they're below the plane. If they're above the plane, they're considered to be positive. So above the plane is counterclockwise direction, right? Because if you try to rotate something in the counterclockwise direction with your right hand, your thumb points up, right? Or you can think of it another way. With your right hand, if you take a screwdriver and you try to rotate in the counterclockwise direction, the nut comes up, right? Or the screw comes up. That's the positive direction. Counterclockwise, positive direction. Clockwise, you're tightening, things go inward, that's a negative direction. It's really that simple. So the moment of F1 is pointing in a clockwise direction, so that's a negative quantity. What about moment of this force F2? So if you look at F2, F2 is going this way. This is the point of interest. Draw a circle, right? Draw a circle. Imagine this is a wheel. If you apply this force F2 on this wheel, the wheel is going to rotate in the counterclockwise direction. So the moment of F2 is actually positive. So if somebody said, give me the net moment of both of these forces about this point, you will compute the moment of each of those forces individually. You look at their signs and you add them up. That's it. So your final answer may be positive, your final answer may be negative. And in some cases, the final answer may be 0, in which case we will see it will be called equilibrium condition. All right? Okay, so that's it. This is how you determine the direction of the moment. Any questions about this, right? Because if you learn this now well, you'll have a much easier time when you take 260. Right? You would have 0 problem in 260 then. For 3-dimensional problem, you'll just do the cross products, okay? So this is what it's showing you. This is for those guys who actually believe in doing this using cross product rule, and that's fine too. The counterclockwise direction is positive. So I'm assuming that I hat and j hat, which is your xy plane, in that plane you have the forces and all the distances, and then cross product gives you distances which are perpendicular to that plane. Okay? Any questions about how to compute the magnitude of the moment or the direction of the moment?
What do you mean when you're drawing the circle, the perpendicular distance?
The perpendicular distance is used to compute the distance between the line of action and the point of pivot or the interest. So like in the previous slide, this is the force F. Perpendicular distance from this point to this line of action is you draw a line that is perpendicular to this. That is the perpendicular distance. Right? Any other questions about magnitude computation or direction?
L
L is given to you. So it tells you what is the distance.
when you do it by
Oh, when you do by component, then the component is f cosine theta. And this is already perpendicular to this, right? So that's same as L. So L is given to you. So, of course, some geometric information has to be given to you. You can have negative moment, right? That's what we have here. For F1, the moment is negative because it is causing the nut to rotate in a clockwise direction. And that is a negative moment. Clockwise is negative, counterclockwise is positive. That's it. That's all you need to remember. Okay? Any other questions about these two slides? This is important, right? If you get this right, you'll have zero trouble in this chapter.